Okay, let's unpack this. I want to start today with a mental experiment. It's going to sound a little mundane at first,
Oh, we like these.
maybe even a little boring, but I promise, stick with me on this, because this specific image is actually, I think, the key to understanding, well, the future of the global economy.
Okay, no pressure then. I'm intrigued. Where are we going?
We are going to a sidewalk. It's a hot afternoon, you're thirsty. And standing right there in front of you is that big, humming, glass-fronted monolith we all know so well, a standard vending machine.
Okay, yeah, I can see it. Classic imagery, the little coil spirals. You've got the bags of chips just sort of hanging on for dear life.
And maybe there's a Snickers bar just sitting there, right in slot E4.
Right, E4. Got it.
Exactly. Now, I want everyone listening to really visualize the actual mechanics here. What happens when you decide, I want that Snickers bar?
Well, you dig in your pocket, pull out $1.
Maybe it's a bit crumpled, you smooth it out, and you feed it into that slot. The machine pulls it in, then you press E, and then you press 4.
And the machine just, whirs to life. You hear the mechanics start to move.
Right. But pause the film right there. Stop. What actually happened in that split second inside that metal box?
Well, it performed a logic check. A very, very simple one.
It verified 2 objective truths, right? 1, did I receive valid money? Is this a real dollar?
And 2, do I have inventory in slot E4? Is there actually a candy bar there?
It's a conditional check. If the answer is yes and yes again.
Then dispense candy. The coil turns, the Snickers drops.
But here is the magic part. This is the part we all take completely for granted. Who stood between you and that candy bar? Was there a shopkeeper there negotiating the price?
Oh, of course not.
Was there, I don't know, a lawyer drafting a quick contract to ensure the delivery of the chocolate?
Definitely not. That would be a very expensive Snickers.
Was there an escrow agent, someone holding your dollar in trust until the candy was successfully dispensed to make sure the whole thing was fair?
No. The machine itself is the enforcer. The machine is the escrow agent.
That's it exactly. The contract, the agreement that $1 equals 1 candy bar is hard-coded. It's built into the metal and the silicon of the box. It is self-executing.
You don't have to trust the machine to be nice. You don't
Well,
hope it's having a good day.
You don't have to trust it, to be honest. You just have to trust the mechanics, the code.
And that is the perfect analog for what we're talking about today, because what we're really doing is taking that metal box from the sidewalk and, well, blasting it into the cloud.
We're talking about building vending machines for things that are way more complex than snacks. Imagine a vending machine for, say, a personal loan,
Or a vending machine for an insurance policy.
a vending machine for voting, or for corporate governance, a machine that runs 24/7.
That can't be unplugged.
And that treats a billionaire in a skyscraper exactly the same way it treats a college student in their dorm room.
We are talking, of course, about the fundamental infrastructure of crypto. We're talking about smart contracts.
And can we just say, that is a terrible name.
It really is. It might be one of the worst branding mistakes in the history of tech. It's up there.
Smart contract. It sounds like a PDF that argues with you.
Right. Or some kind of legal document that uses AI to, I don't know, sue you automatically.
And it's neither of those things. It's not smart in the way we think of artificial intelligence, at least not yet.
And it's not a contract in the legal sense, piece of paper signed by 2 people that you take to a judge.
So if you had to rebrand it right now, what would you call it?
I would call it programmable money, period. That is the most accurate, most descriptive term.
Programmable money. I like that. Feels right. We spent a lot of time on this show talking about the what of crypto. We've covered tokens, we've talked about NFTs, we've looked at Bitcoin as digital gold.
All the assets, basically. The things you buy and sell.
Exactly. But today, our mission is different. Today is about the how.
Right. Because when people throw around a term like DeFi, decentralized finance, what is actually doing the financing? How does a system let you swap tokens without a CEO, without a company?
How does a platform lend you money without a bank manager sitting there, looking at your credit score and approving the loan?
The answer is this machinery we're about to dive into. It's the engine room.
It is, and we are going to explore the core themes that make this all possible. We're going to look at that if this then that logic, which is, it's the DNA of this entire system.
And we have to talk about a really heavy, really important concept called immutability. The idea that once this code is launched into the wild, it cannot be changed. Ever.
Which sounds, honestly, a little terrifying. It's the difference between Google's old motto, don't be evil, and a system that can't be evil.
It is a massive double-edged sword, as we are definitely going to see. We'll also cover the fuel that runs this machine, a concept called gas.
And maybe most importantly, we have to talk about how this digital machine actually sees the real world, something called oracles.
Yeah, that's the bridge.
And we promise, by the end of this hour, we are going to show you some real-world applications that go way, way beyond just trading dog coins on the internet. We're talking about real estate, supply chains, even inheritance.
This is a fundamental shift in how the global economy could operate. It's a new set of rails.
So let's dive in. To really get this, I think we have to rewind the clock a bit. Most people, they think smart contracts started with Ethereum back in 2015. But the concept is actually way older than that. It's older than Bitcoin itself, isn't it?
It is, yeah. To get the origin, we have to introduce a figure named Nick Szabo. This is back in the 1990s.
The 90s.
The 90s. And Szabo is this fascinating polymath. He's a computer scientist, a legal scholar, a cryptographer, just a real renaissance man of the early digital age.
So what was he looking at back then? I mean, the internet was barely a thing. Most people were still on dial-up.
He was looking at the legal system, and he saw inefficiency everywhere he looked. He saw lawyers, he saw delays, he saw ambiguities in contracts.
Billable hours.
So many billable hours.
Yeah.
He realized that a lot of what lawyers and contracts do is just if this then that logic, but it's wrapped in expensive suits and legal jargon.
So he had this idea, I can write code that acts like a lawyer, or at least enforces the deal.
In a sense, yes. He theorized that many of these agreements could be replaced or at least automatically enforced by computer code. He's actually the one who coined the term smart contract.
No way.
And he used that exact vending machine metaphor we started with. That was his analogy back in the 90s.
Wait, hold on a second. You're telling me this idea existed before the technology to actually build it was available? That sounds like, I don't know, Leonardo da Vinci drawing a helicopter 400 years before the internal combustion engine was invented.
That is a very, very apt comparison. Szabo had the blueprint for the engine, but he didn't have a chassis to put it in. He didn't have a vehicle.
Why not? Why couldn't he just run his smart contract on a regular server somewhere?
One word, trust. If you ran a smart contract on a central server, let's say a bank's server, what's stopping the bank from just deleting it?
Or changing the code to benefit them.
Or just turning off the server if they don't like the outcome. There was no trustlessness. He needed a platform that was neutral, a platform that no single person or company controlled.
He needed a blockchain.
He needed a blockchain, exactly. But Bitcoin didn't exist yet. And here's the interesting part. Even when Bitcoin did arrive in 2009, it wasn't enough for what Szabo truly envisioned.
Why not? I mean, Bitcoin is secure. It's decentralized. Why couldn't it run these complex contracts?
This brings us to probably the most important analogy for this entire deep dive.
Okay.
You want to understand the difference between Bitcoin and Ethereum and why smart contracts really live on Ethereum and not so much on Bitcoin. You have to think in terms of gadgets.
Okay, lay it on me.
Bitcoin is a pocket calculator.
A calculator. That feels, I don't know, a little insulting to Bitcoin. We're talking about $1 trillion asset.
Not at all. And I say this with the utmost respect for Bitcoin. Think about a classic TI-83 calculator. It is a masterpiece of engineering for what it does. It does one thing, math, and it does it perfectly. It never crashes. It's robust. It's incredibly secure in its function. Bitcoin is the same. It is designed to do one thing perfectly. Move money from address A to address B.
It's a digital vault and a transfer system?
Yes. It checks the signature. It updates the ledger. It's designed to be simple and secure. But its functions are limited. You can add, you can subtract. But you can't run a complex simulation on it. You certainly can't play Call of Duty on your calculator.
Okay, fair enough. So if Bitcoin is the calculator,
Then Ethereum is the smartphone.
the smartphone, I see where you're going with this.
Vitalik Buterin, the creator of Ethereum, he looked at Bitcoin and said, this is amazing, but it's limited. He wanted to create a platform that could run any program. So he introduced a Turing-complete programming language, which is called Solidity.
Okay, Turing complete. That sounds like some heavy jargon. What does that actually mean for the listener who isn't a computer scientist?
In simple terms, it means you can write any logic you can possibly imagine. If you can describe it in logical steps, you can code it on Ethereum. The calculator is limited to just math.
But the smartphone.
The smartphone Ethereum allows for complex conditions and loops. You can write code that says, send money, but only on a Tuesday. Or send money if the price of oil hits $100 a barrel.
Or send money, but only if 3 out of 5 people agree and sign this transaction.
All of that. That upgrade, that move to a Turing-complete language, is what turned the digital calculator of Bitcoin into a digital world computer.
A world computer, that's a big concept.
It's huge, but, and this is a really crucial point, that added complexity comes with a cost. A calculator almost never crashes or gets a virus. My smartphone gets bugs all the time.
You're adding complexity, so you're adding what developers call an attack surface. More places for things to go wrong.
Precisely. You make the system infinitely more powerful, but also infinitely harder to secure.
Okay, so let's properly define the core properties of this smart contract now that we know where it lives. What makes it different from just, a Python script running on my laptop?
There are 3 core properties you absolutely need to remember. First, it is autonomous.
Meaning it just runs by itself.
Yes. Once it is deployed to the blockchain, it just runs. You don't need a human sitting there pressing a run button every morning to wake it up. It's like releasing a bird into the wild. It just flies on its own, following its programming.
Okay, autonomous. What's number 2?
Number 2 is decentralized. This is critical. The code is not running on a single server in Jeff Bezos's basement.
Right.
It is running on thousands and thousands of nodes computers all over the world, all at the same time.
So you can't just bomb a server room or get a court order to shut it down.
Exactly. It is incredibly resilient and censorship resistant. And third, it is deterministic.
Deterministic meaning?
It means there is no ambiguity. If I run the code on my computer and you run the exact same code on your computer and someone in Antarctica runs it on theirs,
we all get the exact same result. Every single time.
Every single time. There's no maybe. It depends on how the judge is feeling today. The inputs produce the exact same outputs for everyone. It is pure math.
Okay, so let's get into the DNA of this thing. We've used the buzzwords, but how does the logic actually function in practice?
Well, the good news is you don't need to know how to code in Solidity or Python to get the concept. At its heart, the logic is universal. Every single smart contract, no matter how complex it seems, boils down to one simple structure.
Which is?
If a condition is met, then N, execute an action.
If this, then that. It honestly sounds too simple to be revolutionary.
But when you apply that simple logic to money and you run it on a decentralized computer, it changes everything. Let's walk through some real examples to make this stick.
Yeah, let's do it.
Because if this, then that sounds abstract until you apply actual dollars and cents to it.
Yeah.
So let's say crowdfunding, the Kickstarter model.
A classic Web 2 example. I have an idea for, I don't know, a revolutionary new type of coffee maker. I go to Kickstarter, you, the listener, you like my idea, and you send money to support my project.
Okay, but where does that money actually go?
It goes to Kickstarter's bank account.
Exactly. They hold it. They are the trusted middleman, the escrow.
And I have to trust them. You have to trust them, and the creator has to trust them. If the project hits its funding goal, say $100,000, Kickstarter promises to send the money to the creator.
And if it fails, they promise to refund you. But it's all based on promises. What if Kickstarter goes bankrupt tomorrow? What if they decide to freeze the funds because they have a policy against your coffee maker?
Right. Or what if their payment processor blocks the transaction for some reason? You are completely reliant on that third party's honesty and competence.
Now, let's swap that entire system out for a smart contract. How does that look? It's purely code. You would write a contract that says, condition, if the total funds sent to this contract address are greater than or equal to $100,000 by, let's say, December 31st.
Action A. Then automatically and instantly release all those funds to the creator's wallet.
Exactly. And you add an E statement, a fallback. Action B. If a game is not met by the deadline,
Then allow all the original contributors to withdraw their funds back immediately.
the code itself acts as the escrow.
It's the escrow, it's the auditor, and it's the bank all rolled into one unstoppable program.
No middleman required. You don't have to trust the creator not to run away with the money early, and you don't have to trust a platform like Kickstarter. You just have to trust that the code works as written.
Which is a huge mental shift. Okay, let's try another one. Flight insurance. I think everyone listening has had that horrible sinking feeling when you're at the airport, you look up at the departure board and you see that word in red text, canceled.
Ugh, it's the worst. And then the real nightmare begins, right? You have to find your policy number. You have to go online, fill out some complicated claim form.
You have to call customer service and get put on hold and listen to smooth jazz for 45 minutes.
And then, after all that, you have to prove to the insurance company that the flight was, in fact, canceled. You are immediately in an adversarial relationship with them.
They have the money, and their entire business model is based on not giving it to you if they can avoid it.
They are financially incentivized to find a loophole in the fine print. Oh, sorry, that was a weather event. That's covered under Clause 4, Section B, which you didn't pay for.
Exactly. Now, strip all of that away. Replace the entire insurance company with a single piece of code on Ethereum. You pay, say, $20 for a policy. That money sits in the smart contract, not in a corporate bank account. It sits in a public, transparent escrow.
The code is just sitting there watching the flight status from a reliable data source. The logic is dead simple. Condition. If flight hashtag UA123 status officially equals canceled.
Action. Then instantly send $500 USDC, a stablecoin, directly to the user's wallet.
Instant payout. The second the flight status is confirmed as canceled in the system, the money moves. That's it.
No forms, no arguments, no human on the other end deciding if your reason was valid or not. The condition was met, the action was taken. Period.
It moves from an adversarial system that's based on promises and arguments to a cooperative system that's based on pure execution.
That is genuinely powerful. Okay, one last example. And this one is the absolute backbone of all of DeFi. Uniswap, the automated market maker.
Right. This is where it gets a little bit more complex, but stick with us because it's the same principle.
Yeah.
In the traditional stock market, if you want to sell a share of Apple stock, there has to be a buyer on the other side of that trade.
And a broker or a big Wall Street firm matches you up. There's a guy in a suit involved somewhere.
Always. Or a market maker. A big bank like Citadel sits in the middle, constantly buying and selling to keep things moving. But Uniswap is a decentralized exchange. There is no guy in a suit. There's no company. It's just a robot, a smart contract.
So if there's no one to match my order, how does the trade happen?
It uses something called a liquidity pool. Just imagine a big digital bucket with two types of tokens in it. Let's say ETH and the stablecoin USDC.
Okay, a bucket of money.
And the logic is simple. Condition. If a user sends 1 ETH into the pool.
Action. Then the contract's code calculates the new price based on a fixed mathematical formula, and it sends the equivalent value of the other token, the USDC, back to the user.
Oh, and it automatically takes a tiny 0.3% fee and gives it to the people who provided the money for the bucket in the first place.
Well, it's just math. It's just a formula constantly balancing a scale.
That's it. It's an automated formula. Token X comes in, token Y goes out. It runs 247. It never sleeps, never takes a lunch break. And it treats a hedge fund trading $1 billion the exact same way it treats a kid in their bedroom trading $50.
And that universality is really the key. But, and you know, there is always a but when we do these deep dives. This total reliance on code leads us to our next big topic, the double-edged sword.
Immutability.
You hear the Maxes chant it all the time. Code is law. It sounds like a line from a dystopian sci-fi movie like Judge Dredd.
It does. But it's the fundamental core philosophy of this technology. And defining immutability is really simple. Once you deploy a smart contract to the blockchain, the code cannot be changed.
Ever.
Ever.
Okay, let's start with the good side of that. Why is that something we would ever want? Why is that a feature?
Trust. Let's go back to the bank example. You sign a contract to the bank for a savings account that pays 2% interest. But buried in the terms of service, it says they can change the terms at any time.
Sure, and they do. Next month, it's 1.5%. Then they add a new monthly fee. They can freeze your account because of a system error or a suspicious transaction.
The smart contract guarantee is different. If I put my money into a DeFi lending protocol, I can literally read the code myself or trust an audit of the code. I know exactly how it will behave. And because it is immutable, I know that the developer can't just wake up tomorrow, decide he wants to buy a Lamborghini, and change the code to send all the user funds to his personal wallet.
So it removes the human element of corruption or greed or just changing your mind.
Correct. The developer cannot rage quit and change the rules of the game after you've already started playing. The rules are locked in.
So that's the good. Total predictability and trust in the code. Now, let's talk about the bad. The dark side of this.
Permanent bugs.
Oof. Yeah, that sounds bad.
In the traditional software world, think about the apps on your iPhone. Bugs are annoying, but they're temporary. If Apple discovers a major security flaw in iOS, what do?
They push an update, I wake up, my phone is updated overnight, and the problem is solved.
Exactly. They patch it. In the world of crypto, there is no update button. There's no patch for a live immutable contract. If a hacker finds a bug, a loophole, in a smart contract that holds $100 billion,
they can exploit it.
They can drain every single penny. And because the code is immutable, the developers can't just pause it or undo the transactions. They have to just sit there and watch it happen. The machine is doing exactly what the code allows it to do, even if what the code allows is a catastrophic theft.
We have to talk about the biggest case study of this. This is the one everyone points to. The DAO hack of 2016. This is basically legendary in crypto history, isn't it?
It is the origin story of the biggest philosophical split in the entire community. So the DAO was the very first major decentralized autonomous organization. You could think of it like a massive democratically run venture capital fund, all run by code.
And they raised an insane amount of money for the time, right?
$150 million, which was a massive amount back in 2016. It was something like 14% of all Ethereum in existence was sitting in this one single contract.
So the whole community is euphoric. This is it. This is the future. We've done it.
And then a hacker found a tiny crack in the window. And it wasn't a hack in the sense of guessing a password or breaking into a server. It was a logical flaw in the code itself, something techie called a reentrancy attack.
We don't need to get into the weeds, but the basic idea is he tricked the contract into letting him withdraw the same money over and over again before the contract to update its own balance, right?
Yes. It's like he was dipping his hand in the cookie jar faster than the jar could count the cookies. Before the contract could write down, hey, you already took your money, he was already asking for it again. And the code, following its logic, just gave it to him.
So the entire community is watching this happen in real time. They see the $150 million draining away. You can literally see the robbery happening on the public blockchain. Why didn't they just stop it?
Because code is law. The machine was running as programmed. They couldn't just unplug it because there's no central server to unplug.
Yeah.
And this created a massive existential crisis.
I can imagine.
Half the community was screaming, we must stop the thief. This is obviously wrong. We can't let a criminal destroy this entire project and set us back years.
And the other half, the purists.
They said, no.
Yeah.
Absolutely not. The second we intervene, we break the core promise of immutability. If we bail this out, we are no different than the banks bailing out their friends in 2008. The code allowed it to happen, therefore the hacker keeps the money.
Wow. Talk about a moral and philosophical dilemma. So what was the resolution?
They went for the nuclear option. They decided to do a hard fork.
Explain that for us. What is a hard fork?
The majority of the developers, miners, and the community decided to literally rewrite the history of the blockchain. They created a new version of the Ethereum ledger, and in this new version, the hack simply never happened.
They turned back time.
They turned back time and moved the stolen funds to a recovery address. That version, the one where the bailout happened, became the Ethereum we all know and use today.
But not everyone agreed to go along with that.
No. The purists, the ones who truly believed in code as law, no matter how ugly the outcome, they refused the change. They stayed on the original chain, the chain where the hacker kept the money. That chain is now called Ethereum Classic.
That is wild. So Ethereum Classic still exists today as a monument to that principle of absolute immutability, even when the result is a massive theft.
Exactly. And to be frank, the ethos has shifted since then. We rarely, if ever, see bailouts now. The ecosystem is just too big. The general consensus is that the onus is on the developers to get it right, which is why we rely so heavily on third-party audits before any significant contract is launched.
But there is a bit of a nuance here, isn't there? Because I know protocols do upgrade. We had Uniswap v2, now we have Uniswap v3. How do they do that if the original code is immutable?
That's a good catch. There is a technical workaround that has become the industry standard. It's called proxy patterns.
Okay, simplify that for us. No code.
Imagine two separate contracts. Contract A is the proxy. Think of it like the front desk of a building. It's the permanent address that users always interact with.
Okay, so it's a public face.
Right. But contract A doesn't actually have the core logic. It doesn't have the brains. It just points to another contract, contract B, which has all the real logic.
Ah, so contract A is just a signpost. It directs traffic.
Exactly. So when the Uniswap team wants to upgrade from V2 to V3, they just deploy a completely new brain contract C. Then they, as the owners of the proxy, just tell contract A, hey, stop pointing at B. From now on, point at C.
That's very clever. So the address I'm sending my transactions to never changes, but the underlying logic behind it can be swapped out.
Yes, but, and here's the giant risk, this reintroduces centralization and trust.
Because if the developers control that pointer,
they could, in theory, point it to a malicious contract that just steals all the user funds.
So we're right back to having to trust a small group of people.
To an extent. The common fixes for this are things like time locks. where any change to the pointer has a forced 48-hour or 72-hour delay, giving users time to see the change and exit the protocol if they don't like it.
Or requiring a DAO vote.
Or requiring a vote from the community of token holders to approve the upgrade. It's always this delicate balancing act between security, flexibility, and decentralization.
It really does seem like there's no free lunch in crypto. Every design choice has a trade-off.
Never. There's always a trade-off.
Speaking of no free lunch, let's talk about the cost of lunch. We've established the machine, we've established the logic. Now we need to pay the electric bill for this whole thing. We need to talk about gas.
The fuel for the world computer.
This is honestly one of the most confusing and annoying parts for new users. You go to send $20 of some token to a friend, and your wallet pops up and says, okay, that will be $5 in gas fees. And you think, what? Why? Why isn't this free? I can send 1,000 emails for free.
It's a completely fundamental question, and the answer goes back to that idea of Ethereum as a single computer that is shared by the entire world.
Right, the world computer.
Every single transaction you make, every line of code in that smart contract you interact with has to be executed and verified by every single node, every computer helping to run the network.
All thousands of them.
All of them. And that takes real electricity, it takes up hardware storage, it's a real computational cost.
So the gas fee is me paying all those people for their work, for renting their computers.
You are. Gas is the unit of measurement for computational effort.
Okay, give us a scale of effort. What's cheap and what's expensive?
A simple transaction, like sending ETH from my wallet to your wallet, is the baseline. That costs a fixed 21,000 gas units. It's like sending a text message. Very simple.
Okay, cheap.
Now, swapping tokens on Uniswap, that's more complex. It requires mathematical calculations. It requires reading and writing to the contract storage. That might cost, say, 150,000 gas.
Much more expensive.
Minting a complex NFT. That can involve a lot of custom logic and data storage. That could be 300,000 gas or more.
So the more work the network has to do on my behalf, the more gas units my transaction consumes?
Correct. And the final formula is pretty simple. The total fee you pay is the gas used multiplied by the gas price.
And that gas price is the part that fluctuates wildly.
Exactly. You should think of the gas price like Uber's surge pricing, or the toll on a highway during rush hour. If the network is empty at 3 a.m., the toll is cheap. You can offer a low gas price and your transaction will go through.
But if everyone is trying to buy the latest hot NFT drop at the exact same time,
the network gets congested. It's rush hour. And to get your transaction included in the next block, you have to outbid everyone else. You offer a higher gas price to effectively bribe the network validators to pick your transaction first.
Okay, so it's a supply and demand market for block space. That makes sense. But there's another more technical reason for gas, right? Something about stopping the entire machine from crashing.
Yes. This is one of the most brilliant parts of the design. It's the solution to something called the halting problem.
That sounds ominous.
It is in computer science. Imagine if I was a malicious coder and I wrote a smart contract with a very simple but deadly command. Print the word hello forever. An infinite loop.
Okay, like when a program on your computer freezes and you get the spinning beach ball of death.
Exactly. Now imagine if I could deploy that infinite loop to the world computer. Every single node on the Ethereum network would get stuck trying to execute that loop forever.
The entire global network would freeze. It would crash Ethereum.
It would completely grind to a halt. But gas prevents this. Because every single computational step, every print hello, costs a tiny amount of gas.
Yeah.
And you only attach a limited amount of gas fee to your transaction.
Eventually, my money runs out.
Exactly. The network will try to run your infinite loop for a few milliseconds. It will burn through your entire gas fee, and then the program will throw an out-of-gas error and stop execution. Your transaction fails.
And the network is protected.
It protects the blockchain from being spammed to death. It's an incredibly elegant solution that uses economics to solve a fundamental computer science problem.
That is actually really, really smart. Okay, we're getting deeper into the machine now. We've established that smart contracts are these powerful, autonomous logic machines, but they have a fatal flaw, a built-in blind spot.
The Oracle problem. This is honestly one of the most important concepts to grasp if you want to understand how crypto actually connects to and interacts with the real world.
So explain what you mean by blind.
A blockchain is a total introvert. It lives entirely within its own digital world. It is omniscient about things that happen on the blockchain. It knows with absolute certainty that Alice sent 1 ETH to Bob. It knows the exact balance of wallet X.
What?
But it is completely blind to the outside world. It has no idea what the current price of Tesla stock is. It does not know who won the Super Bowl. It does not know if the temperature in Tokyo is hot or cold.
Why does that matter so much?
Let's go all the way back to our flight insurance example. The logic was, if flight canceled, then pay user. How does the smart contract know the flight was canceled?
Right. It can't just Google it or check the airline's website.
It can't. It has no native ability to make an API call or connect to the internet in that way. It needs someone or something to feed it that external data.
Okay, so why don't we just have a guy at the airport who is the designated data enterer? Or why can't we just connect the contract to the United Airlines website's API?
That's the Oracle problem. If we rely on a single guy or a single centralized API like the United Airlines server, we are right back to the problem of trust. We've decentralized the execution, but centralized the data.
If the guy lies or the airline lies.
If he lies, he can trigger the insurance payout to his own wallet. Or, more likely, if United Airlines doesn't want to pay out all these insurance claims, they could simply have their server report flight on time, even when it was canceled. If your source of truth is centralized and corruptible, then your trustless smart contract is worthless. Garbage in, garbage out.
So what is the solution? This feels like a deal breaker. I hear the name Chainlink thrown around a lot in this context.
Chainlink is the industry standard solution to this problem. It is a decentralized Oracle network.
A decentralized Oracle. Okay, how does that work?
Instead of asking one guy, what is the price of Ethereum? A smart contract will make a request to the Chainlink network. Chainlink then, in turn, asks 20 or 30 different independent sources for the same piece of data.
So it asks Coinbase and Binance and Kraken and Gemini.
All of them. It crowdsources the truth. It's like a jury of data providers. It aggregates all the answers that it gets back. It automatically throws out any outliers. So if the Binance API is glitching and reports that ETH is worth $0, Chainlink just ignores that data point.
And then it averages the rest to find a consensus.
It averages the rest to arrive at a highly reliable, tamper-resistant truth. And it delivers that single data point back to the smart contract on the blockchain.
So it serves as the secure bridge between the digital on-chain world and the physical off-chain world.
Without decentralized oracles, DeFi as we know it literally would not exist. A lending protocol like a Aave needs to know the price of your collateral to determine if you should be liquidated. A derivatives platform like Synthetics needs to know the price of gold to let you trade synthetic gold. Oracles are the eyes and ears of the blockchain.
That is a huge aha moment for me. The code can be perfect, but it's useless if it's blind. Oracles give it eyes. Okay, we are heading into the home stretch here. We promised at the top that we would talk about real-world use cases. We've covered a lot of finance, but let's talk about things that impact normal people, things beyond just trading tokens.
Let's look at 3 or 4 scenarios where this technology could legitimately replace entire industries, or at least massively streamline them.
Scenario 1, real estate. I bought a house a few years ago, and it was a complete nightmare. The closing process took over 30 days. I had to pay thousands of dollars to title companies, escrow agents, for wire transfer fees. It felt like I was operating with technology from the 19th century.
It's an incredibly antiquated, paper-based system. You are paying all that money for people to manually verify paper documents and for the privilege of them holding your money in a bank account for a month.
So how does the smart contract version fix this?
Imagine the deed to the house is represented as an NFT, not a cartoon ape, but a unique, non-fungible token that is the legal digital title to the property.
Okay, the deed is a token.
The smart contract is the escrow agent. It holds the NFT deed. You, the buyer, send your cash, let's say it's USDC, a stablecoin, to the contract. The contract now holds both the asset and the payment.
Digital escrow.
Then a decentralized oracle can be used to verify that the conditions for the sale are met. It checks the digital inspection report. It checks the county records for liens. Once the conditions are met, funds received, title is clear, inspection passed, the swap happens instantly.
Instantly, not in 30 days.
In about 10 seconds. The contract automatically sends the NFT deed to your wallet and the USDC to the seller's wallet. The cost drops from thousands of dollars in closing fees to maybe $50 in gas fees. The time drops from 30 days to 10 minutes.
That is a genuine disruption. That puts a lot of people out of a job.
It's inevitable, I think. The only barrier right now is getting the legal system to officially recognize the digital deed as the source of truth.
Okay, scenario 2, supply chain management. This one is maybe less sexy for consumers, but it's huge for global business.
Let's talk about vaccines, or fancy sushi, or anything that needs to stay cold during shipping.
Cold chain logistics.
Right. A pharmaceutical company ships a batch of vaccines that must stay below -20 degrees Celsius. Currently, if that shipment arrives at the hospital spoiled, it's a huge mess. The hospital blames the trucking company, the trucker blames the warehouse blames the manufacturer. It's a mess of lawsuits and finger-pointing.
What's the smart solution?
You embed small IoT sensors, Internet of Things devices, in the shipping container. These sensors record the temperature every 10 minutes, and they push that data to the blockchain via an oracle.
And the smart contract is just sitting there watching that data feed.
The logic is simple. If at any point the temperature data -20 degrees Celsius, then the contract automatically marks that shipment's token as spoiled, and it can instantly issue a refund to the buyer from an escrow account.
No arguments, no lawyers.
The data is the truth. The data triggered the contract. The driver knows it, the buyer knows it, the manufacturer knows it. Accountability is automated and indisputable.
Scenario 3. Wills and inheritance. This one is a little morbid, but incredibly practical.
This is often called the dead man's switch.
How does that work?
A huge problem in crypto is people die, and nobody knows their private keys, and their millions of dollars in assets are lost forever. So you can set up a smart contract to prevent this. The logic is, if my wallet has been inactive for 12 consecutive months,
Meaning I haven't signed a single transaction from it?
right, you haven't moved anything,
Yeah.
then automatically transfer all the funds and NFTs from this wallet to my wife's wallet address.
So if I'm alive and well, I just need to remember to send a tiny transaction once a year just to poke the contract and reset the timer.
Exactly. You send yourself $1, it costs a few cents in gas, the clock resets, I'm still here. If you don't reset it for a full year, the contract assumes you are incapacitated or gone, and it executes your will automatically.
No probate court. No lawyers taking a 10% cut of the estate.
Just code.
Smart. And finally, let's touch on DAOs. We mentioned them with the hack, but as a concept, decentralized autonomous organizations.
This is the big, grand vision. The idea of a company that is run entirely by code and its community. The smart contract holds the company treasury.
So the CEO can't just decide to use the company funds to buy a private yacht.
There is no CEO. There might be leaders, but they don't have unilateral control of the funds. The logic of the treasury contract says, funds can only be moved from this wallet if a proposal is made and more than 51% of the governance token holders vote yes on that proposal.
Total financial transparency.
And total control by the shareholders or token holders. No backroom deals. The CFO can't block a payment they don't like. The money physically cannot move unless the community publicly votes for it to move.
It's a truly radical reimagining of human coordination.
It really is. It's still early, but the potential is enormous.
I want to close with something that feels a little bit like science fiction, but it's actually starting to happen right now. We're seeing the collision of two of the biggest technological trends on the planet: smart contracts and artificial intelligence.
This is where I think the biggest explosion of innovation and, frankly, weirdness is going to happen in the next decade.
Right now, as we've said, smart contracts are rigid. They're kind of dumb. If A, then B.
They're just simple scripts. But in parallel, we are seeing the rise of AI agents, autonomous bots that can think, plan, and execute complex tasks.
But an AI agent, a piece of software, needs a bank account to operate in the real world. It needs money. And I assume that JP Morgan isn't going to give a checking account to a Python script.
Exactly. A bank wants a social security number. They want a photo ID. They want a human to sue. An AI can't provide any of that.
But an AI can have an Ethereum wallet.
Yes, an AI can be given control of a private key. And this opens up a wild vision. The idea of an autonomous economic entity.
Walk me through that scenario. What does that look like?
A smart contract is created that owns a pool of capital, say $1 million in stablecoins. It then grants access to that capital to a sophisticated AI agent with a simple prime directive. Your goal is to trade on decentralized exchanges like Uniswap and increase the balance of this fund.
So the AI is the portfolio manager.
The AI operates 247. It analyzes market data. It executes trades to make a profit. But here is the kicker. From its profits, it pays for its own server costs on Amazon Web Services. It uses the money it makes to pay for better data feeds. It could even use its funds to hire human freelancers, paying them in crypto, to design a new logo for it, or to write code to upgrade its own trading algorithms.
You're describing a robot that owns property, hires humans, and pays to upgrade its own code.
That is the definition of an autonomous economic entity. And smart contracts provide the financial rails, the payment infrastructure, and the property rights for AI to operate independently within our economy without needing permission from any human or any government.
That is simultaneously the coolest and the most terrifying thing I have heard all day.
It's the ultimate logical conclusion of this technology. It's an economic life form.
Wow. Okay, so let's try to wrap this up. What does this all mean? Let's bring it back down to earth with a summary.
To boil it all down, smart contracts are just code that runs on a blockchain. The simplest way to think about it is that vending machine. They give us security, automation, and trustlessness by removing the human middleman.
And that core principle is code is law.
Which brings that incredible trust and predictability, but also requires extreme caution because you can't easily fix bugs. Immutability is a powerful feature. Not a bug, but it can hurt sometimes.
We pay gas as rent for using the world computer.
And we absolutely need oracles to bridge the gap to the real world so the code isn't operating in a blind vacuum.
I have a little piece of homework for everyone listening. I want you to verify this for yourself. Don't just take our word for it.
Yes, this is the best part. You can look under the hood.
Go to a website called etherscan.io. That is the public block explorer for Ethereum. It's like Google for the blockchain. In the search bar, look up a famous contract. Look up USDT, which is the Tether stablecoin, or maybe a popular NFT project like the Bored Ape Yacht Club.
When you get to the contracts page, you will see a tab that's labeled Contract. Click on that. Then click the button that says Read Contract.
And you will see the raw functions of the machine. You'll see a function called balance of. You'll see one called owner. You'll see total supply.
You are looking directly at the engine. There is no hidden corporate back-end server.
Yeah.
It is all right there in public. You are looking under the hood of what might be a new global economy.
It's a really powerful feeling once you realize what you're actually looking at.
It really is. Total transparency.
And that brings us to the end of this deep dive. Next time, we are going into the shadows. We are going to be talking all about privacy and security coins.
Right. Bitcoin and Ethereum, for that matter, are transparent. Anonymous, but transparent. Everyone can see your balance if they know your address. But what about projects like Monero? What about Zcash and its shielded pools? What about tools like Tornado Cash?
Are they just tools for criminals and money launderers? Or are they essential technologies for preserving human freedom and financial privacy in an age of ever-increasing surveillance?
It's going to be a fascinating and probably controversial one.
I cannot wait. For everyone listening, trust the code, but always verify the logic. We'll see you next time on The Deep Dive.